Hello and Assalamualaikum. So today we are going to present our MATLAB project that is tensile test calculator. So my name is Muhammad Uzair bin Muhammad Shukri and my matrix number is 202457.
My name is Umar Hadari bin Zahiri. My matrix number is 200520.
Hello, my name is Umar Akmal bin Zulkifli and my matrix number is 203234. Okay, so I'm gonna start my part with the introduction of our project. As you know, a system of engineering stress strain has been one of the common industrial design nowadays. This could be test, experiment, tension, and compression test. To be more clear, specifically material could be used in order to determine the strength when the load applied. Okay, in this tensile test, stress is known as sigma, where the load applied is proportional to area of the specimen. Meanwhile, strain, we're basically to find the percentage of elongation. Typical use the software system in order to get the accurate value, rather than running experiment in lab manually. MATLAB is one of the program that simple calculate the value and estimate the mechanical properties from stress strain diagram. Also, the engineer used the MATLAB as one of the platform to show the design. Indeed, from the scientific method. This software could show roughly of the project or the experiment and automatically enhance the graphic. Okay, that's all.
So for the next one is the project background. Why we chose tensile testing is because the tensile test is a very important test for engineering nowadays. Tensile test is used in almost all engineering fields. For example, aerospace, automotive, construction, electrical, and also mechanical engineering. We decide to do this program because this program will help the other engineers and also our future selves to get results more faster and more accurate. This program can measure the optimum strength of material that can withstand before it breaks. This program also allows the user to calculate the engineering stress and the engineering strain of an object to make sure that it complies to the standard strength of the object. Yes. So for the pseudocode, we have 4 steps: getting input from user, calculation, the 2D plot, and the 3D plot. So for the getting input from the user, we enter instructions to include we enter the coding to input the value of force, the value of length, the value of initial length, and also the value of the radius. And also for the calculation, we put in the coding to calculate the length equal to length over 1000, the initial area to pi times r square. Also the engineering stress, force over initial area, engineering strain equal to length minus initial length over initial length. The true stress equal to force over initial area times length minus over initial length. And then for the true strain equal to log bracket length over initial length. Also, and then for the 2D plot, we plot engineering strain against engineering stress. And then we also plot true strain against true stress. Also, and then for the 3D plot, we 3D plot the graph x of y against x, y against x against z, in which the y for the first graph we put y length, x is force, and the z is engineering stress. So for the second graph, y is length, x is force, and z is the engineering strain. the third graph, we put y equal to length, x is the force, and z is the true stress. And then for the last 3D graph, we put y is equal to the length, x is the force, and z is the true strain. So that's all for the pseudocode.
So for this, so for the script file, the script file is divided into 4 parts. That is, the first one is input, and the second one is our coding for calculation, and the third one is our coding for the plot 2D, and the last one is our coding for plot 3D. And so we divide it into 4 parts.
So for the control structure, our program only involves three control structures, which are the relational operators, the equal to, more than, less than. We use that for the mostly for the formula, and then for the 2D plot, we use subplot, and then we plot and we put the label, title. Also for the 3D graph, we also use the plot 3, subplot, and label. Yeah, okay. That's for the control structure.
So for the data input, we put the value of force about 1 by 1. We list it 1 by 1, and then the data will give back the data into the form of matrix. And after that, we put it the length. We list it 1 by 1, and after that, the coding will give back the length into form of matrix also. And after that, we input the initial length is 0.025, and last one we put it initial radius that is 0.0064. So for the data output, after getting input from the user, the coding will calculate the value of engineering stress, the value of engineering strain, the value of true stress, and also the value of true strain. This value will be used in plot to plot the 2D plot and also the 3D plot. So this is the 2D plot where the red line is the true stress versus true strain. Also the blue line is the engineering stress versus the engineering stress. Engineering stress versus engineering strain. So the first 3D plot is the force versus length versus stress, and the second one is the force versus length versus strain, and the third one is the force versus length versus true stress, and the last one is force versus length versus true strain.
When we do coding and insert the data, we can see the shape of the stress strain curve. In this experiment, the shape of the stress strain curve is to show the relationship between stress and strain when load applied to the specimen by tension. This can be created in various ways, either in 2D or 3D. However, the shape is basically shown exactly with the data insert. About the mechanical properties, when we see the curve, we can see that several stages would be formed, such as yield stress, ultimate tensile strength, and also the proportional limit. But this data is not shown due to our main objective is coding the stress strain graph and also through stress strain. When estimate the value, we can see the shape of the curve is almost similar with the theoretical. Plotted graph shows that linear elastic will deform after reach the yield point, then undergo process hardening, which the strain is beyond the yielding point until reach the maximum point of stress. However, some errors should be concerned, such as steps when input the data. This purposely to avoid confusion and wrong estimation. Although the MATLAB can detect errors, but we still have to alert. So the last part of our project is we want to conclude our project. Okay, about the conclusion, we can easy to say that tensor test is make engineer obtain the result more easier. However, MATLAB offers strong possibilities with higher interface graphic. Created program be able to apply in any application such as torsion, compression test, and hardening. Improve the knowledge at once and enhance the computational skills of an engineer. Okay, I think that's all from us. Thank you.
You.
Thank you.